So .NET Logic and applications. It's a tricky subject. I know it's a subject that a lot of people have very strong opinions on, myself included. I'm very much a, right tool for the guy, or excuse me, I'm a guy that is the right tool for the job. And so I'm going to be talking about one tool and how you would use it, but it's got to be the right tool for the job. It's not this tool for every job. And I think that's part of what we struggle with as developers. I'm Ryan Bupp. I'm a .NET team lead at 180 Medical. And this is a talk on why you shouldn't use .NET for everything. Let's see. Okay, excellent. So here's what I'm going to talk about. I'm going to talk about it, and then I'll tell you what I talked about. So pros and cons of putting logic in your database. I'll talk a little bit about why you would do it, when you wouldn't do it. A couple of techniques for doing that. How you can code, how you can test and maintain code quickly, which is very important to me. And then a couple of free and paid tools that we use that you may not know about. So even if you say, man, I hate the idea of using the database for anything other than storing data, maybe you'll pick up a couple of good tools. Okay, 180 Medical, who are we? So we are the largest catheter supplier that you've never heard of if you're not using catheters. We ship 50,000 patients a month, so we're right here in Oklahoma City. We grew from 2 guys in a garage in 10 years' time. We were the largest catheter supplier in the country. Actually, I think less than 10 years. They were larger before I came on, which was about 6 years ago. We're about 15 years old now. So every month we ship 50,000 patients out of our warehouse and some external warehouses. We're in the middle of a migration process where we're actually taking patients from some of our sister companies that are owned by our parent company and pulling into our database. So we'll be at about 75,000 patients shipped every single month when that is all done, which should be pretty early after the first of the year, maybe spring. We do everything for our patients. When the business first started and it was just a couple people in a garage, they tried a couple of pieces of custom or commercial off-the-shelf software, and they threw it away because they wanted to do what they do their way. They didn't want to do it somebody else's way. The owner was very customer service oriented. He was in an ATV accident and hated the experience of buying catheters, and so he went and said, we're going to do it our way, and got into disposable catheter sales. So we track patient details, we track orders, items, shipping, everything. We do the insurance claims. Because we're a national supplier, it's not just like a local hospital. We deal with literally every insurance in the country. I think about 1,500 insurances we deal with, and we're trying to increase that. We send EDI, we do FTP, we literally do everything. The actual technology stack, it's a typical .NET stack. We're MVC. We are running Bootstrap, jQuery, SQL Server, and a lightweight ORM. It's actually a custom ORM. But it's very similar to Dapper if you've used that, just very get in, get out. We were on Entity Framework when we started the process and got out pretty quickly. I'll talk about that a little bit. Overall, it's been super, super successful. We have literally, I think when I came in, we were shipping about 22,000 patients, and in the last 5 years, we've doubled the amount of patients. We haven't added a single user to our business. The parking lot is basically full at that time, and it's still full. I actually have an easier time finding a parking spot now. I haven't had to park in our second lot. They actually built this new parking lot because when you're growing at 30-40% a year, and your user base is growing by 30 or 40% a year, you project growth. And so we moved into this big new building on Northwest Expressway, and then the growth of people just stopped. So we have this big empty parking lot that's sitting next to it. Let's see. Pretty much how we do things, we try to keep everything very lightweight. It's MVC, but as I'll talk about a little bit, we don't have a lot of .NET logic. It's mainly go to the database, get data, put it into models, throw it down at the user. As I said, business logic makes sense in different places. If you're doing presentation logic, you don't throw it back to the database. You say, hey, dummy, you need a number in this field. That's JavaScript. But our .NET layer is really, really thin. The only thing we do there most of the time is security and just simple stuff if we're already there and we don't have to go to the database. Just kind of a general size, we've got 1,100 tables. I don't know if that's a good or a bad thing. Sometimes we've over-normalized a little bit, but we have a lot of tables. We have 2,000 stored procedures, just to kind of give you a size reference. And I would say about 90% of the business logic lives in the database. And so even with our size, with the millions of transactions we're doing a day, with all of the patients and everything moving back and forth, it runs really, really fast. Like, really fast. Okay, so when I say business logic, what do I mean? I'm talking applying the rules that you have to apply to data. Now, sometimes that's rules that this thing must be here, and sometimes it's just a business rule that they hand you, like, before I save a patient, I must have a social security number, or if I'm going to bring up an insurance claim, I need to make sure that I don't already have an insurance claim living out there somewhere. So that's really what I'm talking about just in this presentation. SQL isn't the same as .NET. It has a lot of the same functionality, but it's not .NET. You don't have objects, you don't have inheritance, you don't have libraries that you can pump things through. But I'm talking about pure crunching data, applying business rules, just basic logic, which, as is typical, is almost all the logic, at least where we're at. So, couple of design principles before I get into the why you would do the same. And these are things are the most important things to me, because you can go out and find a list of design principles online. Maintainability, I think, is number one. If I write slow code, if it's maintainable, I can fix it. If I write a giant hornet's nest of nasty stuff that's all bundled together, I can't fix it. Everybody's coming to a system where it's like, you're not enhancing the system, you're replacing it. And it's not because they use the wrong language, it's because it's just architected wrong, it's designed wrong, things are just layered on top of it. It's just so wrong, it's built on a bad foundation, and you can't fix that, not without rebuilding anything. Development time is very important. When I was young and in high school and doing Visual Basic and, QBasic and those types of things, it's like we had DOS, it was really fast. But if I wanted to build a user interface, I used, I think VB2 at the time. It wasn't the greatest language in the world, but it built a window for me. I didn't have to build a user interface. It literally built the window, and I spent my time building the things that mattered, throwing buttons on it, adding the functionality that when you click that button. And so to me, even though some of the things that I'll talk about, it's like with SQL, you don't have to build models. You don't have to build a context layer. All of these other things, while it seems like it's kind of a micro optimization, in reality, the less stuff you have to build, the faster you build it. And going back to that first point, the less I'm building, the more things are maintainable, because things become, even simple things become complex if you just throw enough of them together. Single responsibility and reusability. This isn't one that people typically think of when they're thinking of SQL, but it's definitely a principle that's there. You can definitely do too much with SQL, just like you can do too much with .NET. Sometimes you get this God object or this God function that you just keep adding stuff to. We don't want to do that. And then performance, I think, is when you're straight up comparing the two ways of kind of going about things, performance just blows it out of the water with SQL, and I'll talk about that in a little bit. Okay, so why wouldn't you want to do SQL? First and foremost is familiarity. And this isn't to knock on .NET people, but as the saying goes, or just application development, there's nothing .NET specific in this talk, but as the saying goes, if the only tool you have is a hammer, every problem looks like a nail. And so when I approach a problem, in my tool belt, I've got .NET, I've got SQL, I have other tools. If somebody's a Ruby programmer, that's how they're going to imagine to solve that problem. It doesn't mean it's a bad or the best tool, but familiarity is really a problem. Because our shop operates a little differently than a lot of them, we mainly hire, like full stack and .NET people. And so we're constantly bringing people in, and it's like, well, no, we do it different. And so familiarity takes folks a couple months really to spin up. You can have inefficient code if you're not done properly. Now, this is probably the biggest danger with SQL. If you just write something like you write in .NET where you're looping and you're just locking things, and you just add that up across the database, you're going to have a lot of problems. It's going to be a giant's hornet's nest that you can't fix. So if you're going to write SQL, learn SQL. If you don't know like indexes and query plans, or like a cross apply versus a join, or the difference between a scalar function and a table valued function, those types of things are very important, because with .NET or some other kind of application logic, you're typically dealing with something where it doesn't matter. If your thing takes 10 milliseconds instead of 2 milliseconds because you could have written it more optimally, it just doesn't matter. Because you're typically dealing with one thing at a time. When you're joining out across 30 tables, you should never do that. 10 tables, and you're locking them all up, that's a bad thing. So be careful with that. Like anything, it can be abused. We've been guilty of that a little bit because we're more of a SQL shop than a .NET shop. We have SQL hitting API endpoints and calling .NET CLR procs and things like that, and I wouldn't recommend you repeat that. Another thing that people hate about SQL is they say they can't easily test. Now, I don't know why this is, because I think it's a lot easier, and I'll talk about that a little bit. And then existing architecture. If you say, boy, we could really rewrite everything. Well, you live with what you live in. Even when you decide I'm going to go somewhere, it takes time. I mean, there's reality. Why would you want to do things in the database? So first of all, it's simple. You don't like, if you can build something just in the database, that's all you have to build. You don't have to build models. You don't have to build a data context layer. You don't have to feed it to a controller. You don't need to build an interface, and you can schedule it right in SQL. It never has to leave SQL. And so, like I said earlier, that could seem like an optimization, but it adds up over time. When I have something that I can build that just lives there, and somebody's asking me about it, while they're sitting there talking to me, I'm firing up SQL Management Studio, and I'm writing queries, and I'm pulling the things, and I'm starting to write logic, and it's just faster. I don't have to fire up .NET, wait for it to open, wait for it to build. And like I said, I like to test a lot, and so I'm the type of guy, when I'm writing code, I'm making a change, and then I'm looking at it, and I'm making a change, and I'm looking at it. In .NET, it's like I'm having to waiting to fire it up. It just slows down. Less layers, like I said earlier, less layers, less development, less complexity. So the less code you write, the better, the simpler. Let's see. Transactions are a sticky subject. I'm not saying you should technically everything in SQL is a transaction, whether it's a select or an update. But one of the biggest challenges we have when you're talking about multiple operation pieces of workflows is I go and I do this thing, and then later I come back and I do this other thing. And so if you're in the middle of a .NET process and you're firing, or anything outside of the database, and you go and update logic, and then you come back, you do more stuff, and it explodes, what happens? Well, you're in the middle of something, and that's a problem. With transactions, you can make sure that it all happens or none of it happens, which is, a big bonus. Shared code. So shared code has to live somewhere. If you're in .NET, it's very difficult to get something from SQL to .NET. Like I said, we've done it. You can actually make HTTP calls in SQL. It's kind of silly, versus .NET, you're constantly calling the database. You have a whole object layer most of the time. I hope you have an object layer for calling the database. So if I have some piece of workflow, so let's say that in our world, I save an order and then I need to go do something. If there's a validation that has to run after I save an order. If I save it in the database, I can go do that something. If I have a user interface in .NET that I go and I save something, then I can just call that thing. So it's very easy to reuse code if it lives in a place that's easy to call. Balk versus RBAR, which is row by agonizing row. Many times people confuse something being faster because you're doing them one at a time, where it's like, boy, I can do one of these and it takes half a second, and then so if I do 1,000 of those, it's 500 seconds, but it's just 1,000, half a second. But what's really happening is you're actually, every time you hit that, you're locking it and you're causing contention across the database, and you're doing it for a long time. Most of the time, you can do as much in SQL on 1,000 objects as it takes you to do one in .NET. So the speed is a big help. Now, how fast is fast enough? I mean, I'm not one of those people that's like, oh my gosh, it's 10 milliseconds, but I could make it 7. We got to do it. But the reality of it is that if your patterns are slower, that adds up over time. So if you have a piece of code that you write and say, this is fast enough. I load the page, yeah, it comes up fast enough. It seems a little slow, but it works. That adds up over time. When I come back to that and I change it, or I have new requirements, or I've got 30 other things now that are happening on that same page, it really starts to just blow up and get bigger. And then you find yourself in that spot where now I have this giant web of slow stuff that I don't really know how to fix. When you keep it in the database, not only is it a lot faster, but it's very, very easy to monitor, which I'll cover in a bit. Okay, Ricky Bobby prefers the database. So, couple of examples. And if I'm covering an example and you have a question, please interrupt. This is a high-level talk from the perspective of, I didn't know, do I want to kind of create a little code example project, or do I want to talk concepts? And I kind of find that a lot of the times concepts work because I don't know what everybody's working on. And if I did a small little example, how much could I cover, in this amount of time? And so when we're talking through these concepts, please interrupt. Anybody who knows me knows I like a conversation. So for starters, and I talked about familiarity, SQL has variables. It has if and logic blocks. It's not like, working on a stone tablet. We have a lot of amazing things in .NET. You got the same basic building blocks in SQL. From a perspective of, can you build it? I mean, yes, we can. There's very few things for basic data manipulation that you would need that you don't already have in SQL. So it's really like, which tool is it for the job? So temp tables. Anybody who's worked with me for a little while knows they're like my very favorite thing. Why temp table? Because I grew up as a developer, right? I grew up, my first programming language was the TI calculator. And so I grew up as an application developer. I write logic, I write workflows. A temp table allows me to do that on two things. A, it allows me to do it on a group of data. So instead of saying, if this, then this, if this, then this, if this, then this, what you can do instead is grab some data, plop it in a temp table, and then you say, do this, or update this, where that. Update this, where that. It's the exact same thing. The difference is you can do it on 1,000 or 10,000 records all at once. And if you only need to update 700 records out of those 1,000, you can just do that easily because that's what where clauses are for. It's very fast because when you're working in a temp table, you're not working on live tables. So you're not actually touching the database or locking anything. It's just the initial select, which hopefully if you're selecting large pieces of data, your table's either small or it's indexed. So that even then when you're reading an index, you're still not touching the table because you're doing an index seek. And then when you're all done, you just say, take this stuff and plop it back into the table. It's very, very simple, but it's really the exact same thing I would do in .NET. So the alternative would be, what do? You do the same exact select of these 1,000 things. I cast them into objects, and I've got another slide for this. And then you just loop through them one at a time where you still have to go out and do the database. You're doing all of the same thing. You just have to build a lot more. Okay, user-defined types. We use a few. This is by far the one that we use the most, which is a reference table, which is literally just a list of IDs. And why do we use that? Because we're able to pass variables back and forth. So, for example, you can't build one stored procedure that does everything your database needs all the time. I mean, it would just be too big, and it wouldn't be reusable. So to keep our logic smaller, we will pass things. So for example, if I created 1,000 orders, and then I had an order validation that I needed to say, go validate these 1,000 orders, what we would do is we would take those 1,000 order IDs, drop it into a reference table, which is just a single integer table, and then because it's now a type, you can just pass it to another stored procedure. So that stored procedure takes reference IDs as a parameter, and then it says, hey, go get the data for these 1,000 orders, and then that way we're separating out our logic and not just creating something unholy and awful. Let me go back a slide because I forgot something. I like temp tables. I don't like table variables. They do the same thing, just to compare and contrast a little bit. Table variables at very, very, very small data sets can technically be faster because there's theoretically less overhead to set them up. However, in practice, number one, SQL actually caches the definition of your temp tables. That's why sometimes when you're working with them, if you add a column, it says, hey, that column doesn't exist until you delete it. It's because it actually caches it. So the startup time's not really there. And number two, they perform an awful lot better on any large data set. And I'm talking large, like more than 50, for a couple of reasons. Number one, especially prior to SQL 2016, SQL didn't handle variables well at all. It looks at a plan and it sees a variable and it says, well, that's a variable, it's non-deterministic, I don't know what it is, and I'm not even going to try to track what it is. So even if you have simple logic that says, hey, declare at status ID, set it to 5, now select all my orders where status is 5. It doesn't store a plan that says status is 5. That same statement will run a lot slower than if you just say grab all orders where they're 5. That's gotten a lot better in 2016 on, but it's still something to kind of keep in mind. Secondly is like while loops, and there are reasons to use while loops in SQL. For example, say I have a stored procedure and it must take a single thing because I just built it that way. Or if you need to send an email, every night we send all of our patients emails for their order shipped that day, and we need to do DB send mail. And so in that case, we use a while loop. But if you're using temp tables for a lot of your logic, you'll find your need for using loops and cursors. And I can't think of a reason to use a cursor over a while loop, but you find those reasons just kind of go away. Sir? And thank you for asking a question, first of all. I am not a personal fan of CTEs for a couple of reasons. Number one, familiarity. I don't use them enough, and so it's kind of like every 3 months to 6 months I'll have a reason to use them. Number two, they're similar to cursors where they kind of store this temporary space where it's like they're not like one do it and come back. It's more of a it's almost like it just keeps an open transaction where it keeps looping, and they really tend to work recursively, which is kind of like, it's like doing a scalar function versus a table valued function. That scalar function is going to do it again and again and again and again and again, which is how a CTE will typically work. And so I usually just don't run into a scenario where I need a CTE. Now, I'll still do them if I need to generate numbers from 1 to 100 and create a calendar from thin air. There's actually an example a little later in these slides where I used the CTE because one of the things, if you start storing everything in the database, you're going to have to start to find things. Like, where is that logic? I have a CTE that I just dumped it in a view to make it easy to use, where I'm actually walking the SQL dependencies. So if a stored procedure references another stored procedure, and inside of that it references another stored procedure, I have a CTE for that kind of crawls down inside and then adds a depth level. So you can query this view and say, hey, how many things are more than 5 objects deep? And so it's just kind of a code smell thing. But I just don't run into a lot of reasons I use them. The other reason people use them is, with this CTE, blah, and then go do this stuff. I just use a temp table because then it gets me in and gets me out, and then I'm just working with something, whereas a CTE is kind of like a definition, and then when I'm referencing it below, it's still calling that, and then it just keeps hitting the tables again and again underneath. So I'm not a big fan of them, but maybe I would be if I use, and that's part of the problem is like the familiarity, because I don't like to use them. I don't write them as often, but then I don't like to use them, so I probably would use them more if I used them more. So. Oh, what do you think is different? Right. Right. And I don't like views either for that same reason. Right. It's basically an inline view, and I think that's a very good way to describe it. And some of the issues, and we use views mainly in the application. Like our use case for a view is I've got this list. You know, like we create workflows all over the place. Like here are the things that are there that you need to take care of. Because we're trying to automate a lot of our order work, you know, we'll create a queue, you know, we call them work queues, but we'll create a work queue for something that somebody else has to use or somebody else needs to touch. And so with that, we create a view so that it's easy for our ORM to just build a dynamic statement against it, so that a proc doesn't have to say and/or. But when SQL goes to evaluate that view, it tends to do a poor job because you don't know how it's going to be hit. But I don't mind it from the perspective of, you know, kind of defining a view and then reusing it. I just kind of have the personal feeling of if I grab it and I'm done, you know, I grab everything I need and nothing more, and then if I'm done with it, I don't need any more. But I agree, I would probably use them more if I used them more. So yeah, feel free to correct any of that. Let's see. So yeah, user-defined types. Some of them we'll use two reference IDs. Like we have some assignment factories that generate, you know, numbers based off of that. But for the most part, we get an awful lot of mileage of this just being able to now pass a list of stuff from one proc to the next. Okay, so alluded to a little bit, and this is a really, really, really simple example. But it only gets worse as you become less simple. So if you're doing things in SQL, you run a select, which if you can't read it, I'm just grabbing orders where status is. You do stuff, you update, you do more stuff, which is another difference between a CTE and a temp table. You can update a temp table, and then you pass that back to the database. Now, one of the nice things here is I've never left memory here. SQL, at worst, is hitting its disk, pulling information into RAM, and then operating on it. Sometimes it depends on how you have your temp DB set up. Sometimes it can be on disk, but almost all the time you should have enough RAM. It's data. We should have enough RAM to hold it, you know, in RAM. RAM is really, really fast. You know, if you've done kind of your networking layers, it's like RAM is far faster than hard drive. That's why when you're pulling it from RAM, it's a multitude faster than pulling from the hard drive. So when I'm pulling something into an application, any application, if I run and select data, not only am I pulling it off the drive, I'm actually sending it over the wire, which is another multitude slower than data. I have to open up a database connection, okay? Then I take information and I have to reflect it into a model, which most of the time we're using reflection, which is very, very easy to develop, but it's less fast than if I wasn't using reflection. But almost all the time in applications we use reflection. Then if I'm in .NET, now you've got some people love linked to objects, and so maybe you're operating in them en masse, but most people just do a good old for each and do stuff. You operate on it, and then every single record that you're saving, you send it back to the database, which is opening another connection over the wire. And I know I'm making a big deal out of it, like, oh, it's so slow to do things over the wire. It's still imperceptible to us, but compared to grabbing something that's in memory, which if you're running a query often, it will be in memory. It will actually say, yeah, I looked at these things before, nothing's changed, so I don't even need to go to disk. Or at worst, you know, you're looking at doing an index seek, which hopefully your indexes are in memory because you have enough memory, so it never even looks at the disk. So when you're comparing that to actually sending things out of the wire over, from another server, it's could be 100 times slower or 1,000 times slower. The actual act of if you have like group logic or just bulk updates to do, and you kind of do R bar here again, because that's just the way we do things in applications. Every single time you update that one record, then you're opening up another database connection, you're sending data back over the wire, and you're doing that. The thing that's even slower is, let's say that I bring information into an application, then for every one of those things, I need more information. So now I have to I'm not even doing an update for this thing, I need to go and find more stuff. So like in my world, we deal with invoices. If I needed to go find something out about something related to an invoice, it's not even a one-time, one-record thing. I might have to look at an entire other table, and I might have to do that for every single one. Versus if I did 50 at once, then I could look at that other table for all 50 at once, and I'd only have to do it once. So it's just it's writing it down at a very small level, but from a perspective of how fast it is absolutely just orders of magnitudes difference. And so I've seen a lot of things that people have built that have taken 20 minutes to run, and you rewrite it, and it can take 2 seconds and be done. So a couple of examples here, if you can see it up there. One of the things we do, so I mentioned we send out a lot of orders. So we have multiple warehouses. We print shipments, we create shipments, and we have a lot of use cases for that. One of our use cases is our warehouse manager comes in the morning, and he wants to print out everything that's ready for that day. Another use case is a user has a single order that they want to print. Another use case is I printed these orders at some point in time. Now I want to reprint that same thing. And the fourth major use case we have is, I've got my order shipped for today. I'd like to ship things from tomorrow and print those. And so obviously we want to reuse that shipping logic. We don't want to write 4 different stored procedures because there's a lot of logic associated with this. And so what we want to do is reuse that code. Now, how do we do that? We have multiple parameters. So you see, I can send in a single shipment ID. I can send in a list of shipment IDs, or I can send in a batch ID, which is just an ID that when we print orders, we say, okay, your batch ID is this. So it allows us to reprint them. And so if somebody prints a single shipment from the interface, they send that in. Now, what this stored procedure actually looks like is it takes which parameters it gets, and it just builds a temp table with the shipments, or shipment IDs. And so if you send a single shipment ID, it says, if shipment ID is not null, then stuff this thing in my temp table. If you send these shipment IDs, which we actually have 2 other stored procedures for, because one is go grab everything for today, which essentially looks at our orders, figure out what's supposed to go out, and then it builds that reference table of shipment IDs and just passes it on in. Same thing doing future orders. Go grab things from a future date. Here's your shipment IDs. And so if you get shipment IDs, and then it just passes it into a temp table or a list, I forget exactly which one this one does. If you get a batch ID, same thing. Go select from shipments where batch ID equals, here's your shipment IDs. And so coming at that from 4 different ways, all of the logic below that is the same. It just says, hey, go get all these shipments, join to shipment IDs, go do your thing. Okay, testing. I mentioned testing. So depends on how you want to test. I like to write code and look at it and write code and look at it. It's very rare that I find myself write for 30 minutes and then run it and see if it all worked. And even if I did that, I'm probably debugging it along the way. So with SQL, you can select, with applications and .NET, you can watch it. So I need to build it, run it, debug it, put a breakpoint, and I can say, okay, yep, there's my variable. It's what I expect it to be. In SQL, it's the same thing. The only difference is you don't even have to fire up .NET. You just write code, hit F5, and you can select whatever it is you're building, whether it's a variable, whether it's a list of objects. If it's a whole table, you can look at it and see what it is. You can even query your table of 1,000 things and say, do I have any that don't have a value here or whatever? So just by selecting code, it's really easy to test. For stored procedures, if I had an existing stored procedure, most of your stored procedures are going to have parameters at the top. And so I literally get the definition of it. I erase, create or alter proc. I put the word declare, and now I have variables. And you got to remove the go if you've got a go at the bottom. And so it's just let me set my variables to what they are. If I have a lot of logic listed in there, I put a return somewhere, I put a select, and I say, okay, what do I have here? And so it allows me to very, very quickly troubleshoot problems and get into code. I don't even have to open Visual Studio. I've got SSMS open all the time. I find the offending thing, and I query and I see what it is. If it's doing an update to a table, you comment those out. You got to be safe, but outside of that, it's very, very quick to deal with production problems. Except if you haven't used it. A lot of people have used Union. Not as many use except on a daily basis. Union says, take this data set and add this data set. If you're doing Union all, it'll just add them. If it's Union, it's distinct. Except does the opposite. It says, take my data set and subtract this other data set, which is really, it does that on a field by field by field by field basis. So where would you use this? If you're refactoring a view for performance, if you are taking a stored procedure and refactoring it. If you could take your select from your new view, except select from your old view, and you can see if you have any problems. If I'm building a piece, what's that? Okay. If I'm dealing with something that's affecting millions of invoices, I can literally take millions of invoices, run it through my new code, and I can compare the results to the old code. And I say, okay, when is it different? If I'm changing something, I should see some differences, and I should be able to compare all the things that I expect to be different, and they should be different. The only thing you need to be careful with except, it takes A and subtracts B. It doesn't take B and subtract A. So if you're trying to refactor something that's not necessarily going to be different on each side, or maybe records are changing, you want to do it both ways. Select from your old, except new. Select from your new, except old. Temp tables, can't say enough about them. One of the things I love about them is they just stick around. So if you're using a table variable and you run through code, it's gone. If you're using a temp table and you run through code, now you can select from it and see what's in it. And so it makes it very easy to test and to, just see what's going on in them. Write it down, start again. Don't put SQL 15 layers deep, and this isn't just SQL, but it gets especially bad with SQL. Sometimes we get so into reuse that we just reuse and reuse and reuse, and all of a sudden we're just down. Don't do that. Try not to use triggers, and I'll talk about that a little bit in the next slide. Do work and stop. And that's really what it's about with any kind of language. You don't want to just sprawl and sprawl and sprawl. It doesn't matter if you're doing something simple like just messing with data. Eventually it gets more complicated. Even simple things like at the beginning I was talking about, hey, we don't need to use models. We don't need to have all these layers if we're in .NET. Building a model is really freaking simple. You script it. A lot of the times people just generate them from their database. That's not complicated. What's complicated is I have this orders model, and now I'm building this new orders thing, but by golly, it has one more field. And well, I also need to add this thing to it. And before long, it starts to get more complex and more complex, and all of a sudden now I have this orders model that has all of these different things in it that when it initializes, it adds all this extra work, even though I'm not using it over here and here and here and here, I need it over here. It's very hard to make those decisions and have that forethought of where you need to split things if you don't build them, you don't have to make that thought. If you do build something simple and all of a sudden you need to make it more complicated, then you can. You can always make things more complicated. Okay, so kind of wrapping it all up, and like I said, this is more of like a high-level talk. Our Minion engine, one of the things we use a lot, I wrote it, I didn't come up with the name, but the idea was you have something that does a unit of work, and it's working behind the scenes in the database, and it just does stuff. And so at the time, I think Despicable Me 2 or 3 was out at the time, and somebody's like, that's just like a Minion. So it was. So what do we do with it? We have a definition, and it's actually a tableized definition of this is a thing. So for example, I have a create orders minion that I'll talk through. A minion is a definition of something. A job is an execution of that. So if I schedule create orders, it has a run at time, it has a status. The engine is going to pick it up, and when it starts to run it, it says, I'm now running, okay? Minions can also have reference IDs. So like I said, we pass reference IDs all over the database. One of the ways that we do work and then stop doing work is we just write down reference IDs. That might be a table somewhere, or it could just be in the Minion engine, it's just generic. We literally write down reference IDs and then say, hey, go schedule this next Minion. And so when it goes to run, it says, okay, not only do I know I need to run, I need to create orders, but I also know I need to create orders for these specific patients. And so that way we can break out our logic so we don't get into a spot where I'm doing something and then I'm doing something else within that, and then I'm doing something else within that, and if something fails, it has to accept out or any number of bad things. Reporting, and it's just a really lightweight little engine. It's pretty much exec SP, and it calls the proc that is defined by the minion. But what we'll do is we run that thing. It says, I'm now moving from pending to I'm going to run, and then when it starts running, it goes to running. If it succeeds, well, then it just marks it as good, and it moves on with its life. If it fails, it marks it as bad. It sends us an email. It writes down we just have a try-catch on there that's capturing the exception line, the stack, everything that you would want to know about that error. How many records it updated, it always gives us that. And so when you have a problem, whether it's .NET, database, whatever, when you have a problem, it's like, okay, something broke. How do I fix it? Well, now I get an email that says, this thing failed. I tried to create these orders. And when it fails, I know which patients it was trying to create. I know that it didn't get halfway and break. It either did it all or it did none of it. I know that I can take those same patient IDs, take my create orders proc, and say, my reference IDs are go get these patients from this thing. And I can walk through a step at a time and say, okay, what are you doing now? What are you doing now? So a common way we used to fail was patients have addresses, but addresses are based off of time because you don't live somewhere forever, so we have a start and end date on an address. And so initially when we built this, the patient would be getting orders, and then all of a sudden their address ended, but nobody ever created a new address, and so it fails. And so we went back and we changed the logic to say, okay, if you don't have an address, go give somebody a to-do item over here, go fix this patient's address, pull those people out of my temp table that I'm operating on, and then go forth and work. Most of these are scheduled in SQL Agent. We have a plethora of jobs that run at 4 in the morning and say, go do this, go validate all my orders, go send all my orders to the warehouse, go, et cetera, et cetera. A lot of them are scheduled on the fly. I went and saved an order, go do this other thing. The actual onus for creating this was in our old system. We, like I mentioned, we do a lot of shipping. We have some old UPS software that I have no control over. And that piece of software takes the table that they export to when they're running their jobs, and they literally lock it. They don't lock rows. They lock the whole table. If you're trying to select from it, it explodes. And our old application did. Our old application, around 4 o'clock, people are working in this Access application, and the warehouse manager hits a button to run end of day, and the entire building shuts down. Like literally people's Access applications are crashing. And I'm like, what is that? And they're like, well, it's 4 o'clock, right? And it just does. This is when we go and get our coffee. And so there's this thing that I don't control that I can't fix. Oh no, I've been talking too long. That's my warning. It's like wrap it up. You're pontificating. So I have this thing I don't control. So a warehouse user gets an order and scans it, and this thing has to take that record and make sure that it gets there but doesn't die. So from my perspective, it's difficult for me to even query that table and say, hey, you got more stuff for me, because I don't want to scan this table, and I don't want to do anything with this table because of how this piece of software operates. So when they scan that thing, we want it to roll into that table and actually work. And oh, by the way, it has no error handling, so if it doesn't, if you're doing a select on this table and it tries to insert and it can't get a lock, then it just does nothing. The user doesn't know it failed. It just disappears into the ether, right? It's UPS. Anyway, so then when that happens, what I want to do is I want to take that data and roll it up to my shipment. Now my order can have multiple shipments because some items might go from here, some items might go from there. It's just like any other business where you do drop shipping. And so when something marks as shipped, I know that that shipment is shipped, so I have to roll that status up to my shipment. Then, if shipment A is shipped, but shipment B is not, my order's not really shipped, it's partially shipped. So when I'm updating the status of a shipment, then I need to roll that up to an order. But then when my order ships, I need to do more stuff. I need to go and create the next month's order, which I already mentioned can fail because they might not have an address. So my nightmare is like somebody scanning something in the warehouse, and then it's calling code to roll the status up, which is calling code to create the order, which is calling code because they don't have an address, and the thing fails and it doesn't even tell them. So how do we handle that instead? We actually have a trigger, and I hate triggers. I hate the word, I'm sorry. But the easiest thing for me to do is on insert on this table, just take the primary keys because it's, it has an identity seed. Just drop them over here. Do nothing, but just drop them here. So then our engine goes and picks that up and says, okay, I have these specific IDs. I don't have to read the table. I don't have to scan the table. I have a list of primary keys that I'm going to pull data from this table. And then it rolls that up, puts it in the shipment, and then it stops. It says, hey, now this isn't a trigger, but because it's updating the shipment, I know the order IDs while I'm doing it, so I just go and I schedule the next piece of it. And it stops, it's done. If something explodes along the line, I know about it because I get an email and I know exactly what failed. I can go find it, I can fix it, and then I can just rerun that exact same job once we deploy the code, which I didn't mention earlier, I should have. One of the very, very best things about having some logic in SQL, if I make a change, I can just drop it in production. Now, I don't code in production, obviously, we would never, right? But if in theory I wanted to in the middle of the day, I can make a database change. I don't have to deploy my whole application. I don't have to build it. We can run it through some user testing, but it's just very, very easy. You can spot the logic problem, and you can just say, okay, it's now out there. Run it through your test environment, run it through state, whatever you're going to do. But it's now there. There's nothing to build. There's nothing to deploy. Our deployment's a little slow because we have so much code and we have so many things. The slowest part of it, we're using SSDT for our database deployment, so that's like 80% of our build time. By the time I take one of our whole .NET project, and if I build it in a branch, then I put it in our development environment, then I move it to test and get it tested, then I stage it in stage, and then I build a production deploy and put it in production. Even if I'm working the whole time on it, that could take 2 hours. If it's a stir procedure, again, not that I would ever do this, but you could edit it in production. If you saw an actual problem, you can fix it, hit F5, and it's done. And so that development time is just a heck of a lot faster. And we do that a lot. We call it low impact fixes. But it's just like fixing a JavaScript problem or a Razor View problem. It's something that I can fix that I don't have to take the entire server down. And we do it a lot. So cover a couple of tools quick. Like I mentioned earlier, one of the nice things about being in something like .NET, you can find references. You have a whole project that you can search, and you can say, hey, Control F, go find this thing, name this thing. They have that for SQL too. If you haven't used Redgate SQL Search, it is actually free. One of the few things from Redgate that's free. I really like that tool. If you want to do what it's doing under the covers, because all it's doing is querying object definitions and building an index, you can query use the object definition function if you know your object ID, or you can query sysobjects, where order create. Why would you write a query instead of using a tool? Well, I can write a query and say, hey, go find me things that have this, but don't have that. So you can do a lot with a query. This is a database group. Use your imagination. Database project I mentioned we have. So our SQL is in the source control. So when I'm in my .NET project and I search for something, I also find SQL objects. That helps if you have it. Mentioned earlier, like finding SQL dependencies. So if you haven't used SQL dependencies and you want a couple of these code snippets, let me know. I use this one all the time, but it's find me everything that has this table name. So find everything that's using orders and is using my ship date, but is not using our deleted check. So if you have this table and you're like, is this thing used anywhere? You can actually query for it, which is really, really helpful. It's better than, in a lot of cases, than find and replace, because if I search for the word patient ID in my system, I'm going to find a trillion things. But I can actually find where patient ID on the orders table is used, and I'm not doing this other thing. So SQL dependencies is really helpful, because at the end of the day, if you're writing a lot of code and you can't find it or you can't navigate through it, it becomes very unmanageable. Not a free tool, but Redgate SQL Prompt is fantastic. If you haven't used it, there's a free trial. Certainly not, paid by Redgate, but this is one of the, there's a couple of tools that it's just like, boy, I love this thing. You can get it for cheaper than 365, but what do you get with it? IntelliSense is fantastic. SSMS has IntelliSense. It's not that great. SQL Prompts IntelliSense is fantastic, especially when you're joining tables. If you're not familiar with the database very well, it actually, it adds foreign keys to the database, or excuse me, to the IntelliSense. So if I'm selecting from orders and I joined a patient, it actually puts the foreign key at the very top. It will look at similarly named fields and put them, it's very good. You'll learn to, instead of me querying my order shipment demographic template table, I just say select from OSDT, because I know that those 4 letters will get me that table. Code formatting is really nice. You can actually adjust how the code formatting works. If you're big into formatting, which I am, I give the tool props that in the main SQL prompt menu, there's actually a command right there to remove brackets, which I hate, so good for them. Code snippets, so like for example, this snippet, I just keep on my, I actually have it as a SQL prompt code snippet, and all my code snippets, I type DB, and then I type the name of the snippet, and it just pukes it out. So if I want to put a big comment, anything like that, it makes it very, very quick and easy to develop, because if I want to know the last time my database restored, I don't even remember how to query that anymore, because I just use my snippet all the time. So it's good, it's bad, I guess. And tab coloring, you notice one of those is production tab, one of those is development. If you've ever run the wrong command in the wrong environment, which I know none of us have, but it makes it very, very easy to tell where you're at any given time. And if not, then you'll learn how to restore from your audit and stuff like that, which is also a good thing. Tab history, also included with Redgate SQL Prompt. It essentially, everything that's in your window, it stores, and it stores pretty much forever as far as I can tell. So for example, I got a ticket today where I was dealing with some of our EDI records, and I know I worked the same issue like 9 months ago. I'm not going to try to crawl out my folders and find it. I'm just saying I don't query this table often, so I looked for the name of the table, and there it is. And it actually keeps the date. You can kind of see currently open up there because I was working on it, but it keeps the date that you last do it. You can see there's colors, so whichever environment I'm in. Fantastic tool. If you're doing a lot of SQL development, love it. Skip 2. What did I do? Okay, Solarwinds. Just an aside here, one of the things I really like about SQL development is it's easy to monitor and fix. So, I mentioned we were on Entity Framework a little bit, and then we moved very quickly off of Entity Framework. What we really moved to is writing stored procedures. It's just very lightweight. We pull stored procedure, we pull data, and it comes into our objects. One of the issues we had with Entity Framework is even if we wrote something that was good, and was good code, it's all ad hoc queries. At the time, we were on SQL 2012, and so you don't get a plan with any ad hoc queries. You can't even really easily track it. There's other tools that maybe you can, but ours certainly didn't. With a stored procedure, it tracks it. With SQL 2016, you have a query store that tracks it. It tracks stats about it. It tracks how many database scans you have. It tracks how long your wait time is. My favorite graph, and that's what both of these are, is the wait time graph, because the wait time says, somebody's trying to get this table, but you're waiting on something else to happen. So that graph on the left is kind of small, is the daily graph. So you can see, right around here, we had something happen, and that was actually overnight, that big blue bar in the middle, but you can just at a glance kind of see what your trends are. Every one of those bars is something that you can hover over. It will tell you how many times it executed. It will tell you how many times you waited. And so, we don't have a very sophisticated way outside of we check this thing, whatever the biggest, ugliest blue bar, it's like snake in the grass. Whichever one is sticking up the most, we just whack it off. Drilling down, I mentioned that graph on the left is the daily graph. The graph on the right is actually hourly by day. You can get it by 10 minutes, you can get it by 2 minutes, whatever you want. And so, how many times have you been at work and it's like, things are slow. Okay, now things are not slow. What happened? I don't know. This is what happened. And so, there's lots of other tools like this. There's Idera. You can actually write your own queries against the query store. It's kind of difficult because it's all in XML. I don't know why Microsoft created this amazing thing for a SQL database and stored it all in XML. Maybe it was written by the .NET team, I don't know. But actual trending and keeping statistics on things and knowing that, gee, this thing used to take 0.1 milliseconds and now it's taking 5 seconds and I'm calling it 100 times an hour, it just makes it very, very, very easy. And that runs, I think it retails about $2K. I think we got it cheaper for a server license. Having trouble here. Summary. So long story short, like I said at the start, SQL is a tool. You can do data manipulation in it. You can do data manipulation in .NET. I think that if I'm going, I don't go out of my way to get into SQL. If I'm making a controller call and I'm doing work and I have information right there, I'm going to write .NET code, enforce a business rule, and then return it. But if I'm already pulling something from the database, it's very quick and easy to do it the other way. The example I mentioned where we had so many pieces of data starting in our warehouse that just cascaded, I never mentioned us going into any kind of an application because we don't. It literally just says, here's this thing, I do work, I'm done. And so even though we have so much interactivity, I can't really stress the scope of how, most of the applications I've worked at, you have this thing, it supports this other thing, which supports this other thing. In the medical world, if you've ever worked in medical business or billing or anything, it's like this thing goes to this, but then it comes back around in this weird way, which goes into, everything is circular and it's just a giant ball. Like even if you try to avoid it, it is a giant ball. So you can't just go in a straight path. You have to go in a path where I do work, I stop, and then something else does the work. And sometimes you come around multiple times on the same path because you just end up on that journey. Bulk processing is a heck of a lot faster, especially if you're doing any kind of go do stuff. Go grab all these invoices that need to have claims created. Go grab all the patients who need orders created, whatever your use case is. If you're already, like I mentioned, if you're already hitting the database, you're already there. Don't go out of your way to go hit the database to add 5 to something. But if you're already in the database, one good example is I'm going and getting data. If I need to go get a insurance claim, but one of the things I want to know is, do I have any other insurance claims out there for this system already? I'm just going to do that in that stored procedure that's my insurance claim get. Go get this thing and, look for this other stuff and attach it as a second and a third and a fourth record set. Hopefully your ORMs, if you're using them, hopefully they can handle multiple record sets. It makes it very, very easy to pull a whole object graph and then just what does the controller look like? It's just this thing is an insurance. I know the second one is the insurance items. I know the third piece of that is the transactions that I already have, et cetera, and then you just pass it on down the stack. Like I mentioned earlier, anytime where you need to update multiple things, go do this, then go do that, then go do that. If you do these first two things and then break, and you don't have any logging telling you what you were doing, and you don't have any way to stop and roll it back, like you just can't do that. You can, if you're committing things to the database, you can go do this and go do this, and then you can write code to unwind it all. But why would you? Why not just roll back a transaction? Unless it's like some really nasty long, like don't have a transaction open for more than maybe 2 seconds, like don't open a transaction for 3 minutes. But outside of that, why would you ever do that to yourself and have to write code to roll something back? Just don't commit it. went over UDTs, very, very simple, but they just allow you to pass complex objects or lists from one proc to the other because didn't mention during that, if you're on 2016 and beyond, I know I mentioned 2016 a lot, I'm a fan. 2016 and beyond, you can use JSON. So one of our use cases that we have is we do a warehouse count where we go and count 900 objects. Now you could do that every time they're entering one row, just go save it, and that's not a bad use case. They wanted to enter multiple rows and then save it at once. Now what that typically looks like in your application is, okay, I've got all this stuff, save that one, now save that one, because you've got like a a supply count item save, and you're just saving one at a time. If you use JSON with SQL, you can actually take .NET and serialize JSON. You do it all the time, because anytime people in .NET are passing something back, most of the time they're using JSON. They just say JSON serialize, go throw it at JavaScript. Well, now with SQL 2016, you can do that with SQL as well. And so it's really just a varchar. And so in your controller, you take this list of many things, you serialize it as a varchar, you pass it into a proc, and you can guess what we do with it. We take that, we select, for OpenJSON into a temp table, and then we join that temp table. Maybe some of those are new items, maybe some of them are existing items. You can just join to your items row and say, does this exist or does it not exist? Database dependencies, you have to be able to find the code. You can't just write SQL. In the old nightmare that I came into when I came to 180 Medical, I learned these things very fast. The guy that lived there before me, it was a very small IT shop, but before we kind of decided we need to build this big enterprise system, they didn't have a test server. All it was production, and they created a proc. When they wanted to make a new version of the proc, it was proc 2, and then proc 3. Now, they didn't remove proc 2 or proc, they just sat around. And sometimes, if that sounds exorbitant, well, they thought so too. So they would come back and say, I'm going to start using number 1 again, the one without a number again, but not remove 2 or 3. So you're seeing 3 and 2. So object dependencies and being able to find things in SQL, very important no matter where you're at. Whether you write code or not, highly recommend using database dependencies. Just performance monitoring, it's hard to monitor applications. You can monitor threads, you can monitor URLs, and you can see, okay, this one URL is taking time. With database monitoring, you can get it down to the statement. You can see how many reads are happening. Is it an index seek or is it an index scan? These things are extremely valuable because, like I mentioned at the beginning, number 1 is maintainability. One of the things of maintainability is being able to find where I suck. And so reporting shows me that. And so I just come back and fix it. Open up to questions. That's pretty much all I had. Like I said, it's a high-level talk. I didn't go really deep into code specifics, but just kind of trying to get you to think about. And hopefully at the very bottom, just a different way of thinking. Any questions? Sir? Yes.
Do you prefer to use temp tables or staging tables within the actual database to allow backtracking if a problem occurs?
That's a great question. The answer is depends on the use case. I think staging tables are amazing. So one example of the workflows that we do, we take a lot of third-party files. Like, for example, I mentioned electronic data interchange. We send some of our orders to a third party. We pull that back. Now, a use case could be, I take this thing, I pull it into .NET, I do all my work, and then I save the tables. What we actually do is we take the order, and we just sit it down in a table. So our EDI 855s, which are an item-level response on I'm going to send your stuff. We actually have an 855 table that's not even, we have staging tables that are kind of not in our main database, like when we're bringing in CSVs and things like that. But yeah, we use staging tables a lot. A lot of our tables, like our main tables, are really sort of staging tables. So for example, in that EDI example, I take all of their data from their file that they send me. I put the kind of the order level down. I put all the items down, and then any responses that are under those items, that all we just stuff in the database. Now that EDI record at the parent level has a status. I mean, we use statuses all the time. Everything has a status almost, because I have this new thing, I drop it in the database, and its status is now pending. I have a workflow that comes in and looks at those records. So, for example, one of the responses that we could get is, I have this item, I'm going to ship it. I got this second item, that's actually back ordered. So what do you do with that? So I have another workflow that says, hey, go look at the EDI 855s, get the ones that are in status 1 and do stuff with them. And that's the stuff that we do. It's straight up queries, we grab it, and then we do. So really the delineation for me is two things. If I am doing something that I think I'm going to need later, I'll stuff it in a staging table, not in our main database because it's source controlled, but I'll stick it out. We have kind of a secondary database where we stick stuff. So if I'm tracking a special project, or if somebody sent me a CSV file they want loaded, I just stuff it over here, because you just stamp it down, and it's really easy to take a table and mash it up against another table and be done. But anything even coming in externally, we just stuff a status on it and work it. And if it blows up, we get an email, we go troubleshoot it, we fix it, and then life goes on. So we use them both. Any other questions? Sir. Mm-hmm. Mm-hmm. Mm-hmm.
One thing he's mentioned to me that I haven't been able to figure out the proper level unit testing.
Sure.
Is that something you have experience with?
Yeah, I mean, yeah, I will. So what he's asking about is unit testing in SQL. So, I mean, what is a unit test? You can build a test database. I mean, you can build a test project in .NET, and build tests, and it's a great framework. For starters, with a unit test, like some of the things I mentioned for testing is you compare A to B. So anything you do in .NET, you can do in SQL. Now, one of the things you could do as a unit test, even if you wanted to use .NET's unit testing that's built in, is say, build this test and go call a procedure. Like if you really wanted to get into unit tests for SQL, you could create a test schema and put test order create, and then say, okay, go run this thing, and then go pull the results in and see if it equals what I want it to equal. One of the things I really like is, what's really a valid test? If I'm doing a unit test on a UI, maybe I'm going to automate clicking a button, and I want something to happen. If I'm doing a unit test on, I just changed the store procedure that affects every invoice I put through my system, which affects my financials, which I better not change, then I need to make that as wide as possible. And so that's really, I think, where there's an advantage and disadvantage, because there's not extensive unit test frameworks natively for SQL. But at the same time, like I mentioned in the start, if you're going to have your code somewhere, it's very easy to get from .NET down into SQL. It's just that easy. So you can either use .NET to call it, or you can just straight up write your own test procedures and have them run. You could schedule them after a build, and say, go do this thing, go call the store procedure, go select the data, go, whatever's a valid test for you, go run this workflow, or go select this patient that I know has this result. And if the results are different than I'm expecting, do something. But I can definitely see the argument over kind of the unit testing. I like unit tests. We honestly don't do them where I'm at, just because it's kind of the old, I can build the tests, but then the tests take more time. But if I build the tests, then I'll save time because I'll spend less time. I mean, Right. Well, and one of the issues, and this is just something specific to my environment, we had 2 guys, and that was the IT shop. And so then it was like, no, you need a bunch of people, because you can't build, like, what you need to build, I think hundreds of millions of dollar business. For the thing that you need to build, it takes more than that. And so historically, we kind of started off really small, smaller than we should have been. So it's almost like just trying to get it going. Now, over time, we've fixed that and we've paid down a lot of tech debt, but unit test isn't one of those tech debt. But we do a heck of a lot of testing on any change that's coming out. We have audit tables and everything, so anytime we're updating data, if I were to write data down wrong, because at the end of the day, that's really what it's about. Every application that we deal with, we're storing data, unless you're building some kind of utility or app or whatever where the data is. For us, it's all about the data. And so if something goes wrong, which sometimes it does because we also have a very quick development cycle, the flip side of that is if something's wrong and I update transactions incorrectly for our invoices, I have an audit of it, I have backups, we can find the problem, fix the problem, and then we can go deploy the fix, and part of that fix is go fix the data that we broke. So we're a little lighter on that than probably we should be, but we also have the flexibility, to fix it when it goes wrong. Sir.
You mentioned that 90% of your business is in source procs.
Yes, sir.
Can you talk about the good component that's in source control?
Yes.
Then you also said you put under production and you make changes. So what do you do? How do you do source control?
Sure.
Changes?
Sure. And it's really just how urgent is it really? How risky is it? How urgent is it? And how big is the change?
My question is more like, what do you use? How do you use it?
Sure. So we don't deploy directly to production using source control. We're actually using SQL Server data tools, and our data tools builds that. So one of the things that we have to be careful of, if I'm literally just going out to production and changing a procedure, it's not in source control. The next time I'm building my database project and pushing it up, it's going to say, hey, that thing is different than what I have. I'm going to overwrite it. So it's kind of like a situation where you can be out of sync with source control, which happens for any kind of source control. Sometimes you change what's there. We don't, fortunately in our environment, it's not government. It's not, it's a private company where we've been able to maintain the leeway to do kind of what makes sense. So it's not our first goal to go out and just go change production and have it out of sync. But one of the things when we're getting ready to push the next sprint, one of the very first things we do is we compare the database from production to our staging environment and say, is anything different? Because staging is always built off of source control, production isn't so much. And so if there's any differences, like maybe we updated an index or we changed a store, like anything, we do that. So as we're checking in and we're moving up our environments, source control is building them all. And then when we're doing an actual push, we make sure that we're vanilla. We build the scripts to kind of push everything, and then that becomes our deployment vehicle to push to production. And if you're out of sync, then somebody else is going to come behind you and whack you on the head, because we're also tracking DDL events. So when I update a stored procedure, it actually logs that I did it. And so if I go and change it and I don't put anything in source control, somebody's going to know and they're going to blame me. And so it's really just kind of a do what makes sense scenario. We've got the flexibility to do that, fortunately. I personally, it honestly depends. We have some developers that open up Visual Studio and never leave it, and they do all their development and database project. My personal preference is using SSMS. Now, one of the things about SQL Prompt that I like, the plugin works on both sides of it, but I'm just more familiar in SSMS. So what I'll do is I'll develop sometimes against our staging environment, because it's always up and we have a website, for each, but I can develop in staging. We very, very, very rarely push to it. The only time somebody's messing with it is when we're actually preparing for a deployment, so it's pretty safe for me to go in and play, stamp down a change, and then say, hey, user, go look at that and test. And when they're happy with it, then we work things kind of through the stack. It just depends on whether it's kind of, this is something that's either broken in production or I need somebody to look at it, versus this is new development that maybe we're starting in a feature branch and kind of working up through our test environments. I would say 95% of the time source control is a before thing. even when I'm developing it in SSMS, it's like, that's just because I like to develop there. But when I'm done developing, then I go over to my database project and put it down. Because source control you don't want to be out of sync with. So we try to stay in sync. But for that really urgent moment where it's like, oh, this is wrong right now in production, we have the flexibility to just put it there. You're welcome. Thank you. Any other questions? Good. Well, appreciate your time. Like I said, I'm Ryan Bupp. I'm on Slack. Ping me if you need me or have any questions or arguments or disagreements. If I said anything wrong about CTEs. I did. All right. Thank you.